Question on one of them?
Wait, 7.
X squared.
Oh, yeah, I know. I was like, ooh.
There's only subtract x squared minus 0. x1 minus 0 is 1. X plus x is 2x. 2. Then it would be 1, because then we'd have x squared plus 0x minus 1. And when we subtract x squared minus x squared is 0. 2x minus 0x is negative, negative makes a plus, giving us 3. And that's going to be the remainder over. Yep. Does that make sense? Because if the number is after, so if it had been instead of x minus 0, or I think it was, yeah, x squared minus 0x squared, if it had been the other way, 0x squared minus x squared, it had been negative x squared. Now what we're looking at today is synthetic division. Now, in the past 9 years, there have been some that like long division better than synthetic, but the majority like synthetic division better than long division. Now, there are a few steps in doing synthetic division. And we're going to go on and just start applying them here instead of trying to write them all out. Now, the first main step in doing synthetic division is take whatever we're dividing by, here m minus 3. First off, we're going to set it equal to 0. And then get the term with the biggest exponent by itself. Which for us here just means getting m by itself. So we would just add 3 to both sides. And for what we're doing today, and the main ones that these are useful for is when we're dividing by a binomial, a 2-term polynomial expression, where what we're dividing's degree is 1. Now, any questions about how we got m by itself, or how we set this up with the cubbyhole in line? Huh? Little cubbyhole? Now, the reason we have this is we put the number we just found in it. It's going to hold that number for us. Now, the next thing we're going to do is we're going to take the coefficients from what's being divided. So the numbers in front of the variables. So the number in front of m cubed is 1. The number in front of m squared is negative 13. The number in front of m is 24. And our constant term is 18. And our next step is to drop the first number down. Questions on this so far? We're good with this here so far, yes? Now, I'm going to start using highlighters for this first one here. I would suggest not writing what I write in a highlighter because it's just going to be attaching stuff and showing what's connecting to what and what's going where. And by the end of the problem, there will be a lot of highlighted marks all over the place. Okay. Now we're going to go on and get started. Now the first step is we're going to take our 3 and multiply it with our 1. So we're going to do 3 times 1, which is 3. Now that we've multiplied that, we're going to take this number and place it under the next number above the line. So we get our 3 here. We good so far. Our next step is to add these two here. We add straight down. So negative 13 plus 3 is, so negative 13 plus 3 is negative 10. So we add straight down and put that number below the line. And now we're going to repeat this process again. So we're going to do 3 times our negative 10. Gives us negative 30. And we take this negative 30 and we place it under the next number. And then we add straight down. We add these two numbers together. So we have 24 plus negative 30 is 24 plus negative 30 is negative 6. And now we do our 3 times negative 6, which is negative 18. And we take our negative 18, place it under the next one. Yes. Then we're going to add straight down, and negative 18 plus 18 is 0. Do we have any other numbers left? No, so we're done. Now, what I suggest to do after you get done with the last one is put a box around the last 0. It will not always be 0, but this last number, when we divide it by a binomial, a 1-degree polynomial, the last one will be a remainder. If we divide it by a trinomial, a degree 2 polynomial function, the last 2 would be the remainders. Trinomial, or degree 3, the last 3, it kind of goes out. But mainly we're going to be focusing on degree 1s. Now this last one's the remainder. Now our first step, and kind of, or one of the steps in getting it set up, is we took the variables out. We listed the numbers across the top. Now we're going to put them back. Now the last number is the remainder. The one next to it, our negative 6, is our constant term, our term without a variable. The one next to it, in our case, is m to the first, and the one after that would be m to the what? Second, because we just keep increasing it by 1. If there was a number after the 1, it would be m to the third, then m to the fourth, m to the fifth, increasing by 1. And what that tells us is our final answer is m squared minus 10m minus 6. And since the remainder is 0, we don't have to add it in. That's it. It would give us the exact same value. Let's look at the next one. So we need to get this set up. So the first thing we're going to do is get v by itself. We're going to solve for the value of v. We're going to do that by minusing 4, telling us v is negative 4. and -4 goes in the cubby. Numbers across the top. We'd have 8 for v to the 5th, 32 for v to the 4th. We would have 0 because we don't have a v to the 3rd. Then 0 again for v squared. And then 5 and 20. Yep. We don't have to put, we're not going to put any of the variables, we're just picking the numbers. We get this here. Our next step is to drop the 8 below the line. Questions on this so far? Our first step is to multiply our 4 and the number below. -4 times 8 is -32. And we add straight down, -32 plus 32 is 0. Now we're going to multiply again. So -4 times 0 is 0. Now at this point, we add straight down. 0 plus 0 is 0. Okay. -4 times 0 is 0 plus 0 is -4 times 0 is 5 plus 0, 5. Now we're going to do -4 times 5 is -20. And 20 plus -20 is 0. And we put a box around the last one because that is our remainder. Now the 5, the number next to it would be our constant term, our term without a variable. The one next to it would be v, v to the 2nd, 3rd, v to the 4th. Because 0v to the 3rd is just 0. 0v squared is just 0. 0v is 0. We put them in there because we needed those spots for those terms. But now that we're done, we don't need them anymore. So our whole answer is 8v to the 4th plus 5. And that's it. Questions on this here? Questions on any of this so far? Now, if we look at this one here, this one's a little bit different. What's different with this one here? We have 3x minus 1, the 3 in front of that x, 3 in front of the variable with the biggest exponent. Yes, we're going to have to divide it by 3. Incidentally,
Why couldn't you just have 1%?
So x is going to equal -1.
so incidentally, we can't just divide. We have to divide it not just, we have to divide everything by 3. We have to divide everything by 3. Which, luckily enough, 3x cubed divided by 3 is x cubed. 4 will not divide by 3 nicely. So we have -4 thirds x squared. 17 does not divide by 3 nicely. So we have 17 thirds x, and 6 divided by 3 is. Now for the next part, 3x does divide by 3 nicely. We get x. And with the last part, 1/3. Questions on any of this here? Unfortunately, we can't, and part of it, we're not going to do the whole synthetic division or long division. If $17x and we went on out, and we did the first step in long division, what times 3x gives us 3x to the fourth? X to the third power, and then we would go on from there, yes? So if we notice the first number, the number itself has to be 1 times x to the third, yes? Okay. Now, I'm going to erase that there. If we left it alone and left it as this here, going across the top, we'd have 3, -4, -17, 6. Yes? And the first step is to bring down the first term. But we said with long division, the first term was 1x squared, yes? What is this telling me it's going to be? 3. And if we did, and this would end up being 1/3, because we would add the 1, divide by 3, yes? And our first step is 1/3 times 3. But no matter what we do, this is still going to end up being 3. We need it to be 1. That's why we have to divide this. That's why we have to divide this by 3. You know, so hopefully that makes sense why we have to do this division of 3. Now, luckily for us, erase all that. Everything else goes the same as the previous. We're going to set our x minus 1/3 equal to 0. And at this point here, we would add 1/3, telling us x is 1/3. And now we're going to put it in our setup. That needs to be replaced. Okay. Well, the computer's about to die. That's fine. So let's see. Do what you are. I'll give myself a little bit longer. Yeah. Yep. We're going to do this here. So we're going to put the 1/3 there. Our numbers across the top would be 1, -4/3, -17/3, and 2. And we bring the 1 down. And our first step is to multiply the 1/3 by our 1 below, which gives us 1/3. We put it on the next one and add straight down. Now for this here, we can do -4/3 plus 1/3 in the calculator, giving us -1. And exactly, now we'll do the multiplication step again. 1/3 times -1 is -1/3. We'll put it under the next one and then add straight down. And the calculator will do this for us, -17 probability thirds plus -1/3 is -6. And then the last multiplication we need to do times -6. Now luckily for the most part is -2. All the ones we've done up to that point, it's kind of easy to do by hand because we're just multiplying with 1. And our last one, 2 plus -2 is. And if we put the variables back in, The 6 would be our constant term, our term without x. Our -1 would be our term with x. And our +1 would be x squared, telling us that this is x squared minus x minus 6. Questions on this here? Questions on any of this so far? Up to this point, we've dealt with synthetic division when we had a number in front of the x, in our case, of the part that's being divided. Now we're going to look at one where we actually do have a remainder, because all the ones we've done up to this point have divided evenly. And having a remainder is not going to make any real big change. The first part of getting this x by itself still holds true. Putting that value in the cubby is still true. 3, -2, 2, -5 is still true. Bringing down the 3. Now that's still going to hold true. We don't have to do anything if there's a number in front of the variable with the biggest exponent. If it's the one not being the divided, but the one being, or not the one we're dividing, but the one we're dividing by. This can't have a number in front. This can. That's fine. Now we do our multiplication again. -1 times 3 is? Add straight down. -2 plus -3 is? -5. -1 times -5 is? 2 plus 5. -1 times 7. And -5 plus -7. And we put a box around the last one because the last one is the remainder. So this is our remainder. Our 7 is our constant term. Our 5 is our term with x. 3 is our term with x squared. So we have 3x squared minus 5x plus 7 plus almost -12 over x plus 1. And we use the x plus 1 is because that's what we're dividing it by. Questions on this here? Questions on anything we've done so far? But that's it. So even if we do have a remainder, we do have this here. Now, another way we could write this is that we take the negative out front with the 12 and just say minus 12 over x plus 1. Either one of these is correct. Yep. Both of those are correct. Questions on any of this here? What do we think of synthetic division? We like it a little better than long division? Do we need to see another example of one of these? We feel good with these here? In that case, we're going to jump ahead to this here, evaluating a polynomial using synthetic division. It's trying to. And that's why I've got this hooked up in a... Yeah. So it's still, it does let me know when the headphones are going to die, because it just has a beep beep, but it keeps doing until it officially runs out. I don't know if it picks it up on that, but it does get quite annoying listening to it. So for this one here, we want to evaluate a polynomial. Use synthetic division to evaluate. So the first thing we're going to do is just do synthetic division. Now they tell us x is equal to negative 4. We don't have to do anything to it like we did with the last ones. It's already equal to it. 5, 13, 29. We're going to bring the 5 down. Negative 4 times 5, negative 20. Negative 1 plus negative 20 is negative. Negative 4 times negative 21 is 84. Negative 4 times negative 21. Now 13 plus 84 is 97. Negative 4 times 97, 388. And lastly, 29 minus 388, or 29 plus negative 388 is negative 359. And that would be our remainder. Questions on this here? Now let's actually evaluate this the way that we did on Monday. Because if we evaluated it like that, we would say 5 times negative 4 to the third minus negative 4 squared plus 13 times negative 4 plus 29. Yes? And if we hit enter, it tells us that its value is so this step here, I just plugged negative 4 in for x. Well, so here I just replaced every x with, so I'm using the original equation because on Monday when we evaluated, we just replaced x with the number, and it told us if we did this, we get negative 359, yes? What was the remainder when we did synthetic division? So f of negative 4, I'm thinking of the next one, is negative 359. So the value we get when evaluating, plugging it in for x, and the remainder we get when using synthetic division give us the exact same value, the exact same thing. It will. It won't. It'll always give us the same value. I would, since for here it's asking us to do it by synthetic division, I just do it by synthetic division so that we kind of see this. Now this is helpful because, especially if you think back to last chapter when we solved and we graphed the quadratic equations, we were looking for what value of x made the function equal 0. Because if it equaled 0, it was a solution, which means if we evaluate an x, plug it in and get 0, it means it's a solution to the equation, which also means if the remainder is 0, it is a solution. So these are helpful. So let's do another one of these. So it's already set x equals 5, so we're just going to put 5 in the cubby hole. Numbers across the top would be 4, negative 10, and negative 21. And the first step is going to be to bring down the 4. 5 times 4 is 20. We put it underneath our next number. Negative 10 plus 20. 10. 20 minus 10 is 10. 5 times 10 is 50. And lastly, negative 21 plus 50 is 29. So f of 5 is 29. So if we wrote in function notation, we'd say f of 5 is 29. But the answer we're looking for is 29. Questions on this here? Questions on any of this so far? We feel comfortable with these here? Yes? Well, the value we're looking for this here is just 29. Because we're just trying to evaluate it for that given value. So we're not looking for the whole thing. So this is the assignment. Now, before we officially call it a day, there is one more that I want to look at. Plug everything back in. Now, did we get the homework assignment written down? Okay. Now, one of the ones we skipped over was this one here. Now, this one here is a little bit different for the last one, because what we're dividing has 3 terms. Now, for this one here, we do still set this equal to 0. But instead of getting x by itself, we're getting x squared by itself. We get the biggest one by itself. So we would add x to both sides. Minus x squared minus 4 is equal to x. Then we add 4 to both sides. Minus x squared is equal to x plus 4. So it's the one before we evaluate. Right there. Questions on how we got to this point? So okay. For a second there, I thought we didn't do one of the problems, but we did. Now, going across the top is the same as we've been doing. We put the coefficients of our numbers. So 2, 1, negative 15, negative 2, 10, negative 24. If any of the numbers are missing, we put them in as 0. Now, the numbers that go in the cubby, we will still have 4, just like the previous time. But this time, we also have an x. So we put the number in front of x, which is 1, because the number in front of x is 1. If it had been 2x, we would have put 2. If it had been negative x, we would have put negative 1. We put the number in front of x. Now we will draw our line, but we drew one line when we had one number, so we're actually going to draw. Since we have 2 numbers, we were going to have 2 lines. Now we will drop the 2. The 2 drops all the way to the bottom. And we drop the second number down 1. If we had 3, if we had, essentially we're dividing by an x cubed, we would have an x squared term x in constant, 3 numbers, which means we would have had 3 lines, and we would have dropped the first number all the way down, the second number down 2, and the third number down 1. Questions on this here? We ready for our multiplication? Yes? Now all the multiplication will be done with the bottom number. So our first number is 2. So we're going to do our 1 times 2, which is 2. And then we're going to do 4 times 2, which is 8. So the first number, when we multiply with the 2, will go on the bottom line. Our 4 is going to go on the top line. Questions on this here? Now the next thing we're going to do is add. 1 plus 2 is 3. Negative 15 plus 8. Questions on this so far? Now we're going to do the same process over again. So now we're going to do our 1 times 3 is 4 times 3 is 12. And then again, we add. Negative 7 plus 3 is negative 4. And negative 2 plus 12 is 10. Now we multiply again, so we're going to do 1 times negative 4 is negative 4. 4 times negative 4 is negative 16. And then again, we add. 10 plus negative 4 is 6. 10 minus 4 is 6. 10 plus negative 16 is? It is 6, but it would be negative 6. Questions on this so far? Lastly, 1 times 6 is 6. 4 times 6 is? Now we're going to add. Negative 6 plus 6 is? Negative 24 plus 24 is? 0. Another color just because. And we can bring down that last 0 and have it there. Now that we bring the last one down because we don't have any numbers after the negative 24, we can't do this again. Now, this time, how many numbers did we have in the cubby? 2, which means the number of remainders we have is actually also going to be 2. One of them might be 0. We might have 2 numbers, but we will have 2. The farthest to the right in our remainder, because both of these are the remainder, would be the constant. The next one would be the term with x. But since they're both 0, we don't have a remainder anyways. The 6 is our constant term. Negative 4 is our term with x. 3 is our term with x squared. 2 is our term with x cubed. So that there is our final answer. Now, if we did have a remainder, we would just add it in as 0x plus 0 over what we started with. Like that there. But again, the reason I showed you this was because I wanted to show you that it is possible to do synthetic division when we divide by something bigger than a linear expression, divide by something bigger than having a degree of 1. But it might be easier to just do this with log division than it would be to do it with synthetic. But it's up to you. Either way works.